Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And welcome back, everyone. Alright, so we have reached up to the last part of sketching the graph of quadratic function. And for the case 3, we need to consider suppose that when the quadratic cannot be factorized. Okay, so we have 3 steps to sketch this kind of function, which is the first one is we need to do the completing the square, and then we need to state its maximum or minimum point based on the completing the square, and then we can get the x and y intercepts, and last but not least, of course, we'll sketch the graph. Okay, so let us consider now this example. So sketch the following graph and hence state its domain and range. So suppose that we have fx equals to x squared plus 2x plus 3. Alright, so before that, we need to really make sure that this function cannot be factorized. Okay, so we've got the calculator here. So the a value is 1 and the b is 2, and we've got 3 for the c, and when we press equal, we'll see this r here. Alright, so which means it cannot be factorized, and it got the complex root. Okay, so therefore we need to use the completing the square that you have learned in chapter 2. So to save our time for this chapter 4, we will not going through the completing the square process, so where we assumed that you have already get it under your belt. Alright, so this question, we have fx is equals to x squared plus 2x plus 3. So by completing the square, this function can be written as x plus 1 squared plus 2. Alright, so where from the basic form of completing the square, we actually can get straight away its minimum or maximum point. Alright, so for this case, since we have this positive x squared, which means our graph is in its smile shape, which is therefore we will have its minimum point. Alright, so minimum point here, we need to look for this one. We have x plus 1. So equate this equals to 0, and we'll get the x, so which is therefore our x is negative 1, and these 2 here should give us the y coordinate of our minimum point. So therefore our minimum point is negative 1 and 2. So let us try to plot this. So the minimum point, this one is negative 1, and we've got 2 here, somewhere around here, and we which means this is the minimum point, so which means the graph will not passes through the x-axis, because this is the lowest point where the graph can go. Alright, so and we also have the y-intercept for this case. Alright, so y-intercept, which is, I hope that you already spot it, which is this 3. Alright, so this one is the 3 here, and the shape is the smile shape. So let us try to sketch the graph now. We need to make sure that it passes through the y-intercept 3, and yeah, that's it. So the domain for this function is just negative infinity up to positive infinity, since the graph is still valid for any values of x. And the range for this graph is we need to look at the minimum point here, where the graph in the interval of y, where the graph started from 2 here. Alright, so this is the first interval of y where the graph is valid, so which is therefore our range is starting from positive 2 up to positive infinity. Alright, so let us consider this question number 2. Okay, so sketch the following graph and hence state its domain and range. So we have fx equals to x squared plus 2x minus 4, where can be written in the completing the square form after you have done the completing the square, in which we will obtain x plus 1 square minus 5, and therefore since the shape of this graph is a smile shape, we will have its minimum point here, which is -1 and -5. So this one is -1 here and -5 is somewhere around here. So this is our minimum point. All right, and of course we have the y-intercept, which is -4. That is the c value in the function. So this is the -4, and so we just need to sketch the graph now, and the shape is the smile shape. Make sure that it passes through the minimum point and the intercepts. Okay, so since the graph passes through the x-axis, so we need to find the x-intercept here, so which means we just need to make this one, so x plus 1 squared minus 5 equals to 0. So solving this, so should give us equals to 5. So x plus 1 equals to plus minus 5, and x is equals to -1 plus minus 5, where we can write this in this in the decimal as well. So or you can just leave it like that. So we choose to be just make it in that form. So this one should be -1 minus 5. Okay, so for the domain of this function, so we need to write the domain here. So there's no restriction on the x interval for this particular case, so therefore it's still -infinity up to +infinity. And the range of this function, where we need to look for the interval of y where the graph is still valid. And for this case, what we have is the minimum point is starting from here, -5 here. All right, so which means our lowest point where the graph can reach is the starting from -5. So which is therefore the range is close bracket -5 up to +infinity open bracket. All right, so we have done discussing the quadratic function. Next video we will discuss about how to sketch cubic function. Thank you for listening. Thank you for watching. Hope you understand. That's all. Thank you.